Okay, recording, good. Yeah, so my name's Bruce Phillips, as I said. My background is also in kind of fact checking, working for news organizations, also investigating kind of lobby groups, sometimes undercover, working on pushing back against mis and disinformation, particularly on climate change. And I've also presented at COP conferences, particularly on climate education. So the photo you can see there low on there is when I took three students when I was a school teacher for a couple of years as well in Berlin, an international school, and the students got the opportunity to speak to some of the world leaders, which was very exciting. And that particular one was the one just before Greta Thunberg's speech. So we kept her seat warm for her, I guess you could say. Um, so talking about the planetary boundaries. Firstly, let's talk about what the Earth provides for us for free, and then I'll get onto the actual planetary boundaries themselves. So the Earth is basically a safe operating space for humanity, and the Earth has certain Earth systems that help to keep it in three different ways, in three different ways that it helps to keep us basically safe. The first one is stability. For a very long time, basically for the whole of civilization's history, we've had a relatively until recently, relatively stable planet in terms of the climate patterns, the seasonal patterns. It's been fairly predictable as well. For farmers, yes, there've been bad years, good years, but at least the seasons were fairly predictable and fairly stable. So the Earth provides stability. It also provides resilience. So that means the ability to absorb impacts. And this is specifically from human pressures. We'll talk about some of those pressures, which are the strongest ones, which ones aren't so strong, ones that we're actually improving. There are some, you'll be glad to hear, there is some good news, some bad news, but I'll look at both. But the Earth provides stability and resilience. And of course, it also provides habitability. So it basically provides life support. And that life support comes for free. We don't have to pay for it. It would be very difficult to put a value on how much the value of that is and how much you'd have to pay to replace that if we were to damage it in a particularly bad way. So I want to talk you through the kind of the steps in basically civilization history. You all know roughly the kind of humanity's journey on Earth. We came out of an ice age about 24,000 years ago. And then around about 8 to 10,000 years ago, the climate pretty much stabilized. And it stayed in a very narrow band. And that narrow band was good because it was stable. And that allowed us to develop things like agriculture, towns, cities, everything else. And then around about the 1800s, that started to change, obviously. We had something called the Great Acceleration. And what I mean by that is rapid changes in how we're using the Earth, what are we doing to the Earth, and also in terms of our resource use and the changes that humans are making to the planet. Also in that period, of course, I will talk a little bit about climate as well. We've seen a rapid increase in temperatures. To give you an idea, note that the scale there changes on the image there. So we're going from thousands of years to kind of hundreds of years. And it's important to point out, even in the fastest period of warming coming out of the Ice Age, it was still only about 1 degree of change in 1,000 years. And the current change that we're seeing now in literally the last 40 years, we've had 1 degree of change. So we're going from natural changes of 1 degree in 1,000 years to 1 degree in just 40 years, in the last 40 years, that is. So that's a rapid change. And as we know, in general, life struggles to adapt to rapid change, particularly in evolutionary terms. So that is a rapid change. It's still going up the temperatures. There is some good news I can talk about later on, but it's still a massive issue. So going back further than that, so we're going back right back to the kind of start of modern human evolution, about 250, 300,000 years ago. In all that period, the climate stayed within basically this kind of tube you can see on the screen. So this is from kind of -5 degrees up to kind of +2. Okay, so the last time it was hot as it is now globally was about 120,000 years ago. That was the last time it was hot as it was now. The sea level at that point was a lot higher than it was now. It obviously takes time for the sea level to rise, but it stayed in that narrow band. It's likely by the end of this century we're going to leave that tube. We're looking at the moment with the current policies at about 2.7 degrees of warming, maybe 3 degrees of warming. There's some questions exactly how high that might go. Depends on what we do, obviously. But we're leaving that tube of stability, and not just the tube of human civilization, but that tube going back millions of years. So that is the problem. Talking about the great acceleration, these are the kind of the drivers of making the Earth less stable, less resilient, and less able to support life. You can see the socioeconomic trends on the left, and you can see the Earth system trends on the right, and they match because as we've increased our consumption, increased our impacts on the Earth, you could say there's been some improvements in socioeconomic trends. But the point is can we maintain that? And it's unlikely if we're doing what we're doing currently. I can say that. So the planetary boundaries. The planetary boundaries, basically, there's 9 of them, and these are a measure of whether we're in this safe operating zone. What I mean by the safe operating zone is the Earth going to maintain its stability, its resilience, and its habitability? As soon as you go past the planetary boundary, you start to lose that. And you can see where we are on that image there. We're basically outside the safe operating zone overall in 7 out of the 9 planetary boundaries. And I'll talk about those boundaries shortly. In some of them, we're above the high risk line. But luckily, there's 2 that are still in the safe operating zone. But there are 7 that aren't, and that's a problem. So these are basically rules that help to keep life support in a good state, the stability of the Earth systems in a good state, and to keep it resilient, so able to absorb shocks. So these are the 9 planetary boundaries. Some of these you would have heard of. It's unfortunate that obviously these are the scientific names, so I'll simplify some of them. Some of them are obvious, some of them not so obvious what they really mean. So this is what they basically mean. So this first one is freshwater use. So what we mean by that is in some areas we're seeing changes obviously in freshwater use. If you have too much water in one place, that's bad. And if you have too little water somewhere else, that's bad. So for example, what's happening in Devon at the moment, you've got the floods there. You've had, I think 40 days of rain in the UK. That's obviously too much water, and that's a deviation from normal. In other parts of the world, you've got incredibly dry conditions, and that's also a deviation from the normal. Obviously, you do get dry and wet periods. Droughts have happened before, and very wet periods have happened before, but we're going outside those ranges more and more often. So the frequency and also the intensity is getting worse for freshwater use. Part of that is from agricultural use. Part of that is how we're using the water. Part of that's from water pollution and just not having the clean water anymore. And a lot of that is driven by climate change. Because even if you get the heavy rainfall like you've had in the UK, because the global temperature is higher, even if you get these massive floods, people think, well, okay, we shouldn't get a drought this summer, it should be fine. Yes, that can be the case, but as temperatures go up, the evaporation goes up and the soil loses its moisture faster. So we're now starting to see very, very heavy winter rainfall in some countries, and then still getting a drought in the summer just because it gets so hot that the evaporation goes up. And it's roughly around about 7% more water in the atmosphere for every 1 degree of warming. Obviously that has a big effect. The second one I want to talk about then is biosphere integrity. This basically means loss of nature and species, not just loss of species, but also the loss of the relationships between those species. So the integrity is can ecosystems still function properly? The next one's climate change. I can talk a little bit more about climate change later on, but as you obviously kind of know, the more fossil fuel emissions we emit, the faster climate change is becoming. It's getting worse. I can talk about some of those a little bit later on. Next one's land system change. That's essentially forest loss. So in the lab, we basically take satellite data and also ground station data and as much data as we can from all over the world, plug it through our supercomputer we've got on site, which has got about 50,000 computers in it, all run on renewable energy. And even the waste heat from our computer goes to heat up the entire campus, which is fantastic. So it's a supercomputer that is very efficient, and the heat from it basically heats my office and everyone's office on the entire campus with 200 scientists, which is fantastic. But with our supercomputer, we can process all of these different boundaries, and we can work out what state they're in and also what direction they're going in as well. So is it getting worse or better? The next one's biogeochemical flows. This is fertilizer and nutrient pollution. This is particularly relevant because just yesterday I happened to notice this. We monitor this around the world. But I grew up just by the River Ada, just down the coast from you guys in Shoreham-by-Sea. And my parents live quite near the river, and I occasionally just check the river quality. We have the data available to us here in Potsdam. And I noticed a massive spike in what appears to be fertilizer pollution. It might be sewer systems overflowing, but this seems strange. It seems like maybe a farmland has flooded, maybe one of the silage pits, or maybe one of the kind of animal waste pits has overflowed into the River Ada, because normally it kind of stays below about 2,000 is the kind of the level you've got. On 21st of January this year, it went up to 300,000. That's the bacterial count in the water. So obviously, when you add fertilizer to water, it runs off farmland. And generally, in some parts of Europe, about 2/3 of the fertilizer doesn't go into the soil. It gets washed off straight into rivers. When it does that, you get algae growing like crazy. That basically forms this layer of green algae on the surface. Anything else underneath it dies because it hasn't got light. Then it gets broken down by bacteria. And as the bacteria break it down, they use up the oxygen in the water and the fish die. It's called eutrophication. You might have learned about it at school. That is a very severe problem. We've massively changed these biogeochemical flows. So that's the amount of nitrogen and phosphorus in Earth systems has gone up massively. And that's entirely down to artificial fertilizer and the way we're farming. It's possible to avoid most of that. It's possible to avoid wasting fertilizer. It's also a waste of money for the farmers. So we're looking at ways how we can help farmers to monitor where the fertilizer is going, so they're not doing that anymore. And it also obviously saves the money, which is good. The next one is the ozone layer. That is one of the boundaries that is actually getting better. It's stabilized. It's not getting any worse, and it's very slowly recovering. There's been a few years where it kind of drops up and down again. There's one bit I want to talk about the ozone layer a little bit later on. Actually, I'll talk about it now. Actually, it makes more sense. With farming is actually one of the drivers now of ozone layer loss, particularly cattle farming, unfortunately, and also fertilizer use produces something called nitrogen oxide, and this one's called N2O, and this can interact with the ozone layer. It's not as strong as the CFCs that used to cause damage, and obviously we banned CFCs, which was a fantastic idea. But now it seems like farming is one of the drivers, particularly specific types of farming that are driving this. And also an unusual one we discovered just this year was satellite loss. So as you know, there's a lot of Starlink satellites in orbit. These tend to be lower orbit than most satellites, and they only last about 3 to 5 years. When the Starlink satellites, it's not just Starlink satellites, but they're most of them, when they deorbit, so basically eventually they fall back to Earth, and when they burn up in the atmosphere, they release a lot of aluminium oxide, and that seems to be also damaging the ozone layer. So there does seem to be a link between satellite loss and ozone loss. We're still trying to quantify it. It might be a tiny effect. It might be a big effect. We're not sure yet. That's going to come out in our next Planetary Health Check report this September. So yeah, every year we put out a Planetary Health Check report, and that tells us what the state of these boundaries are. Next one's ocean acidification. So this is basically the CO2 from burning of fossil fuels going into the ocean. It forms carbonic acid and makes the oceans less alkaline. They're not acidic yet, but they're going in that direction. Then we've got novel entities. This is basically new pollutants. The vast majority of chemicals we put into the environment are not tested. This is a problem. They're not particularly well regulated. There's a lot of pushback from industry to make sure they're not regulated. And that is a growing problem. And often we don't know the effects of these because we're not monitoring a lot of them. And the last one is atmospheric aerosol loading. So aerosols, these are natural aerosols, and there's human aerosols. So aerosols are basically dust or particles we put into the air, and they either reflect sunlight. Say it again. They either reflect sunlight or they absorb it. So they can either have a heating effect or a cooling effect. Things like soot and smoke tend to have a warming effect, and things called sulfur dioxides or sulfur oxides, these actually reflect sunlight away. And this is one of the reasons why Venus is very bright in the sky. It's got a lot of sulfur oxides in the atmosphere. That's why it looks so bright. And that can actually have a localized cooling effect. Now, when you get a localized cooling effect plus climate change, when you get hot and cold next to each other, you tend to get things like storms. The other impact you have is as we improve air pollution, as we reduce air pollution, and a lot of the air pollution is aerosols, we're going to see that has been masking a lot of the warming from greenhouse gases. So you've got greenhouse gases pushing temperature up, and you've got the aerosols in some regions pushing them down, the temperatures down. As we improve air pollution, it's a bit of a difficult one because obviously air pollution kills millions of people prematurely each year. We've got a difficult decision of we need to reduce air pollution, but we're going to see some of the climate change being unmasked as we reduce those aerosols. So that's just a very, very quick kind of introduction to them. This is how we represent the planetary boundaries. And you can see them changing over the years. And as I said, 7 out of the 9 are now outside the safe operating zone. So the green is a safe operating zone, the yellow is into the risk zone, and the red is into the high risk zone. So yeah, it's a problem. 7 out of 9 are in a bad state. Okay, so that's mostly what I just wanted to say about the planetary boundaries. I see if my time's up there, so I'm ready to move on to questions.
Thank you, Bruce. Shall I turn this round so that you can see me and I'm not obscuring the screen if I sit here? Does that work?
Yep, all good. Yep.
Great. Okay, so as you said, you know, you've broken down the Earth system into 9 subsystems, but they all interact and they all affect each other. Could you maybe talk about the oceans a little bit and perhaps, use that as an example to show how the oceans affect the other planetary boundaries and how those planetary boundaries affect the ocean?
Sure. Yeah. So for the ocean acidification one, this was only passed last year. So this was the boundary we left the safe operating zone. So with ocean acidification, obviously but carbon dioxide going into the oceans forms carbonic acid. That makes the oceans less alkaline. So the oceans are still currently alkaline, but they're heading in the acid direction. That links in with climate change because the oceans have been basically absorbing around about 25 to 30% of our emissions. So the oceans have been basically very resilient. They've been absorbing some of the impacts that we would have felt. So without the oceans there, that CO2 would be in the atmosphere. So that would have sped up climate change. The oceans are basically soaking that up, protecting us from a significant chunk of climate change. The oceans are also absorbing enormous amounts of heat. So as the greenhouse gases slow down energy loss to space, that's what they do. And as we add more of them, they slow down more energy loss to space. About 90% of that energy goes into the oceans. So the oceans are not only protecting us from the worst temperature rises from climate change, they're also absorbing the CO2. So they're absorbing the cause, and they're also absorbing some of the effect of climate change as well. So not just the CO2, but the temperature rise. Also, in terms of the oceans, in terms of what they do for us, they also obviously maintain a huge amount of life in the oceans. That's the biosphere integrity. As we acidify the oceans or make them less alkaline, I should say, that has impact on shelled animals. Those shelled animals will disturb food chains. It also disturbs the algae, and the algae in the oceans are producing enormous amounts of oxygen. So one thing we've also noticed at the lab is that globally oxygen levels have declined slightly. Nothing to worry about yet, I should point out. That's mostly from the burning of fossil fuels. So whenever you burn a fossil fuel, you know this if you think of a fire triangle, you need oxygen, fuel, heat. Oxygen's one of those. So as we burn the fossil fuels, oxygen levels have declined a little bit. And that's an indicator that that's not good. We were hoping that nature could replace that as it absorbs the CO2. Can it put that oxygen back out again? But it's just not keeping up. We're also seeing a decline in the ability of life in the ocean to absorb CO2 as well, and it's becoming less productive. So we've seen maybe an increase in some areas on land from the extra CO2. You might get a little bit of extra growth here and there, but that's mostly weeds, not crops. Most of the crop growth seems to be coming from the fertilizers. The problem, obviously, is if the fertilizers go into the ocean, they damage that ability of the ocean to do its job. In terms of the aerosols as well, the oceans have an impact on the aerosols. The ozone, not so much linked. Land system change, you might not think it's particularly linked. But even in terms of just the cycling of nutrients is very, very important indeed. But that's just the oceans.
Okay, great. Thanks. Well, similar question really about the biosphere. So the concept of biodiversity is fairly widely understood. And biosphere integrity, as you were explaining earlier, is a kind of different thing. Could you explain what that kind of biosphere integrity is, what it means, and how that interacts with the other systems, the other 8 systems?
Sure. Yeah. Yeah. So when we talk about biodiversity, we're talking about the variety of life on Earth and the variety of species. Biosphere integrity is slightly different because this is talking about how the biodiversity actually functions as collectively. So how it interacts with each other, the relationships it has. Particularly with forests, we're particularly focused on kind of forests for this, but not just forests, also the oceans we're starting to concentrate on as well. It's just that we don't know as much about the oceans as we do about land systems. But one of the things we do at the Potsdam Institute is we're actually able to model the biosphere, which sounds strange, but we're actually able to model what would happen if we lose this particular function. So we're noticing, for example, with wildfires, for example, we're seeing overall globally a decrease in wildfire area. Now, that sounds confusing, and there's a reason for that. In terms of the area where we're seeing a drop in wildfires is in grasslands, specifically in Africa. So the majority of grassland fires are in Africa. We're seeing a big drop in grassland fires. And the reason for that is mostly land use change and fragmentation. So as you get infrastructure built, it splits up the areas of grassland, and the area that burns can't grow as big. You've got fire breaks. With forest fires, and this is somewhere where we're worried about biosphere integrity, forest fires seem to be getting worse. They're more severe. The fire season is longer. And in terms of the emissions, in some parts of the world, the emissions are shooting up. Particularly, I think, was it last year? I think it was Spain, or was it Italy or Greece? I don't know which one it was. There's one particular country in Europe anyway that had a massive spike in wildfires. And the problem is as you get more and more frequent wildfires, this reduces the ability of trees to do their job and to function properly. And also, even if they do absorb the carbon, if you get the forest fire, that's just releasing it straight away again. So we are now starting to see a weakening of the ability of nature, and this is the biosphere integrity part, a weakening in the ability to remove carbon dioxide, a weakening in the ability to do its normal functions. This could be water recycling. It could be in the relationships, the productivity of the forests as well. In the Amazon, we're particularly concerned because we're putting so much pressure on it from deforestation, for example, that what might happen is we hit a tipping point with the Amazon where it flips from forest to grassland. So it could reach the point at a certain temperature where even if you stopped all the deforestation, you couldn't stop it swapping to grassland because of the overall damage we've done to it. So it's just not just the climate damage that we've done to it, but also in terms of deforestation and the destruction of biosphere integrity as well.
Okay, one of the things that you pointed out as you went through the 9 boundaries, and one of the things that's really striking when you read the Planetary Health Check report is the extent to which agriculture and the wider food system is implicated in all of the damage we're talking about. The agriculture is the by far the most the worst impact on land system change, biosphere integrity, biogeochemical flows, and water, and it's seriously implicated in the other 5, all 5 of the other ones, including, as you were saying, the ozone layer. What kinds of agriculture and what aspects of the food system are particularly responsible for this?
Yeah, I mean, what we actually did was because we basically tried to come up with what's called the planetary health diet. So people can look that up at home. And what this is supposed to do is to make sure that we stay within the safe operating zone, or bring nature back into that safe operating zone, and are able to feed everyone properly. So it does require a shift in diet. In some parts of the world, it's quite a big shift in diet. Tends to be more the richer countries. In some parts of the world, and it allows them to have more. And one thing we just literally put out a paper last week actually on this was to do with actually cattle. Cattle, unfortunately, is the biggest impact by far. Um, there is the argument from farmers that the kind of pasture land, if they're just grass fed, that it's very good. Um, Unfortunately, the research that we found is that that can be the case in a very small, you know, very small number of places that is the case, and in some parts of the world that is the only option to eat beef or cattle is the only option. But for the vast majority of places, the cattle are not just fed on grass. I know this. I grew up in a farming community, so I know what the cows are also fed on in winter. There's just not enough grass throughout the winter, so that food has to come from somewhere. It's not particularly efficient, and as a result, you have more land use, by particularly for animal farming. Having said that, the planetary health diet we've come up with doesn't mean that people have to totally give up meat. It just means that there's a certain amount they can have. I try to remember off the top of my head. Don't quote me on this. I think it was about 120 grams of beef per week. I think it was, which is yeah, I think about a burger. But that would depend on obviously where people live. Chicken was better than beef. Obviously, plant-based diet is better than that. And it is very much the way we farm. So it is possible. We found out it is possible to feed everyone properly. It's just very much the way we farm. And I think that farmers probably will need support with that to swap over to more sustainable farming. But part of that will have to come from the customers, I think. As with any, I mean, farms are generally a business. So with any business, if the customers are demanding it, then they will supply what the customers want. In terms of food prices as well, the food price tends to come down if you've got a plant-based diet, just because you don't use as much land. And that land that you free up could be turned over to increase the biosphere integrity, to absorb more CO2, and to reduce all these other impacts. So it has kind of co-benefits. One last thing I would say about cattle is we put out a paper just this week, talking about what climate change will do to the availability of grazing lands. So even if we don't reduce cattle, if we don't reduce our fossil fuel emissions, we're going to see up to a 50% cut in grazing land for goats and cattle and sheep by the end of this century. So the suitable land for grazing will be cut up to, in the worst case scenario, 50% loss. So it's not so much a case of in some ways it's not even a case of it's nature basically saying you've got to do this because there's nowhere to feed your cattle. So that was a kind of an interesting finding. But that literally came out this week. So there's likely to be a 50% cut in the available grazing land. So yeah, we have to change anyway, basically, whether we want to or not, really.
Okay, great. Similar question, but this time about war and the defense industries. We know a little bit about carbon dioxide emissions from defense industries. In Amitav Ghosh's book, The Nutmeg's Curse, he says that the Pentagon uses 20% of the US national fuel consumption and more than two-thirds of countries. But is anyone looking at the global military impacts on all the planetary boundaries, all nine of them, including the impact of actual wars?
We're not currently. It's something that is definitely worth looking at because it's a major, it's a major industry. It's a major contributor. What is interesting is that, okay, not currently obviously in the US, but pre the current US administration, we did see a lot of interest from the military in terms of how climate change affects global stability of governments, and in terms of how that might affect some of the boundaries. So I think there was a recognition among some militaries that this was an issue that they have to change, because if they don't change, they're going to cause the destabilization that leads to war. So I think there is the recognition there among some militaries. The British military seems to be interested. They have put out a report on climate change that they're concerned about it, but whether that leads to them changing how they do things, it would be interesting to see. I've heard of some militaries also looking at kind of electric vehicles instead of petrol-driven ones. But even with electric vehicles, it does have impacts on some of the planetary boundaries anyway, particularly novel entities. So I think that's an interesting one. In terms of war, yes, generally, I would say it has a significant impact, particularly land system change. Um, some of the other ones, I'd say novel entities as well, biosphere integrity potentially because of the disturbance to nature, um, but also I guess a shift in where food is going. But I guess that just depends on the size of the wall.
Yeah. I suppose there's a bit of a challenge to the recognition by the military. Wars are good for the arms industry because they get to sell more stuff. But anyway, we'll let that go for now. Um, can we just talk a little bit about your role? You're the Planetary Boundary Science Communicator at the Science Lab and the Potsdam Institute, which recognizes the need to get this frankly disturbing information out there. Who's taking notice? Who's inviting you? What are politicos and administrators doing in response? What questions do they ask?
I mean, I can say that I've from some political parties they ask us for advice. So we're partly government funded, partly privately funded. But one of the things we say to any kind of private funding is that we have to have complete freedom in terms of our research and also our findings. But in terms of people that are interested in us, it's governments, it's policymakers, it's also businesses as well. Increasing number of businesses, they've started to realize that what they're doing is not sustainable. I think a lot of them realize that basically if you keep doing what you're doing and it's going to destroy your business, that's not a good business plan. And they are starting to see increasing impacts, particularly the insurance industry is very interested in what we do as well, because they're seeing massive increases in claims, particularly in terms of climate, but not just climate, in other areas of the planetary boundaries as well, particularly freshwater as well, I'd say as well, they're interested. But it's we are generally aimed at policymakers, but businesses are definitely interested in us. I've spoken with multiple MPs in terms of in Germany to advise them, particularly on what's going on in the US. I mean, science is very much under attack. I've got to say that it really is in the US. We hear from colleagues that work at NASA that have lost their jobs. In terms of our ability to monitor what's going on, that is being shredded in the US anyway. We're losing access to lots of NASA satellites that are going to be decommissioned early. One's on the International Space Station. It monitors CO2 globally, and that's likely to get switched off. It's a perfectly good instrument. It works fine. It monitors global CO2, and that's likely to get switched off. There's a second satellite that is likely to be crashed into the atmosphere to decommission it 5 years early. It's a perfectly good satellite. It's just basically, it appears to be, for me personally, it appears to be fossil fuel lobby industry groups basically pushing this through the US government. And that is a problem. I think in the next couple of days, they're removing the endangerment finding in the USA, which classifies CO2 as a pollutant, basically, causing harm at least. And that's likely to be removed in the next 3 or 4 days. The Environmental Protection Agency is likely to get rid of that in the US. So I had a meeting with some members of parliament to talk about that in Germany, say, well, what can you guys do? Can the European Space Agency help out to recover data? Can they put a satellite up to help us? But generally, our ability to monitor what's going on is difficult, particularly with the amount of heat going into the ocean. We have over 2,000 buoys worldwide that monitor the oceans down to 2,000 meters depth every day, and they can tell us what's called the ocean heat content. And ocean heat content is, as I say, where 90% of the energy from excess energy from climate change goes. About half of those are likely to get decommissioned because of cuts to the US funding cuts, basically. So there's a lot of worried scientists that we won't be able to monitor things, and also potentially we won't be able to see tipping points. I'll just show you some of those actually. So these are just some of the tipping points that we're monitoring. Ice sheets, dieback of forests in the boreal regions of kind of Siberia, also coral reefs, and Amazon rainforest dieback. Also, you might have heard of the AMOC, this current that runs through the Atlantic that brings warm water up towards Europe that keeps us a lot warmer than we'd normally be about the temperature of Canada without it. And we're monitoring that to see if it's slowing down or not. This AMOC current, if it does slow down, and it's more likely to be after 2100 than before, but there's still around a 10% chance of it slowing down beforehand. That would bring basically you'd have most of the planet warming up rapidly, and then Western Europe plunged into extreme winters. Very hot summers still, but extreme winters because this current brings the warm water through the Atlantic to the UK. So that could make it very hard to farm indeed in winter, if not impossible. So that's something else we're monitoring. In terms of what temperatures we're talking about and where we think roughly these tipping points would happen. So a tipping point is where something shifts into a new state. It can be a slow tipping point. It can be a fast tipping point. We look back at Earth's history to work out if it's fast or slow. Obviously, before 1700s, we didn't have thermometers. So we use something called climate proxies. This can be coral reefs. This can be ice core drilling. It can be drilling into the sediment in the ocean. We can even use something called rat middens, which is basically thousands of years of rats peeing in the same place. And you can tell from the layers and layers of their excrement, basically, you can monitor it for different plants and things and work out the temperatures from the past. So this is what we're looking at. We are approaching 1.5 degrees kind of permanently in the next couple of years. We've exceeded 1.5 degrees above pre-industrial a couple of years in a row. That's likely to be passed in the next, I guess, 5 to 10 years, and we'll be at 1.5. Then we've got a genuine risk of the Greenland ice sheet collapse. Again, that won't happen overnight. That'll be over thousands of years, but then it's not stoppable. Tropical reef die-off, maybe 95% of tropical reefs dying off. We've got various currents slowing down. Then as it gets more extreme, you can get to maybe, I mean, to be fair, currently we're looking at 2.7, maybe 3 degrees with the current agreements. So the ones to the right, we hope we don't reach them. But as I say, the error bars on these can be quite wide. It depends. Even going into the risk zone is basically like rolling a dice. And the more you go into that risk zone, the higher the chances become of a problem. So you basically just don't want to be in the risk zone, and you want to get back out of the risk zone as quickly as possible. But that gives you a rough idea of where we're at the moment. And this is from 2022. This will be updated in our planetary health check this year.
Great, thanks, Bruce. I'd like to take questions from the floor now. Bruce, do you want to give yourself a full screen? And can you see the audience now?
Yep, sure. I don't know do you want me to talk a little bit about, I don't know if anyone wants that, just some solutions, because I've just been kind of doom and glooming.
Sure.
If you want me to, yeah, it would take a couple of minutes. Is everyone okay? Yeah, with that? Yeah. Just as individuals anyway. So in terms of, this is mostly about climate, but not just climate, it's about sustainability in general. In terms of your impacts, I assume most of you are able to swap your electricity provider. That does have a big impact. I say to people, a 10-minute phone call and you can reduce your emissions by 10 to 20% with a 10-minute phone call. And people are like, really? Yes, it's as easy as that in terms of swapping away from fossil fuels. Whatever that is, as long as it's not fossil fuels, that has a positive impact generally overall. Obviously, any type of energy production does have an environmental impact, but there are some that are better than others. So energy use is a big one. You can see countries are rushing in terms of energy production or electricity production, I should say, towards net zero. Some are doing better than others. But there are lots of countries that are already there, already at 100% non-fossil fuel electricity. They're not there at energy use yet, but they are there for electricity. And I think there's about 10 to 15 countries have already reached that point. I'd also point out that with fossil fuels, about 2/3 of the energy from fossil fuels produces non-useful energy. So what I mean by that is if someone's driving a car, a petrol car, 2/3 of that energy goes out as heat and noise and non-useful movement, shaking, I guess. but only a third of it actually goes into actually making the car move. And that's generally the case for fossil fuels. So when we talk about energy use, we don't have to replace all of the energy. We only have to replace a third of the energy use. So when you see these graphs showing total energy use, don't worry, we don't have to replace all of that because a lot of that is just wasted energy. Food is a big one. Food waste is a huge problem. Any ways you can help people to reduce food waste has a big impact. Also, this planetary health diet. If you look up planetary health diet on YouTube, you can find it. It gives you an indication of what that is. It's not that difficult. It isn't totally restrictive. You can still eat a little bit of meat if you wanted to. It's not, totally restrictive. It's just shifting slightly the proportions you have. It's not as bad as people think. The next one, I've talked about kind of impacts of different things. Unfortunately, beef is the worst, but there are other ones that are not particularly good. But you can look this up on Our World in Data is fantastic for this. Looking up greenhouse gas emissions depending on the food type. Voting has a very, very big impact in terms of policy. When we put policies forward or we suggest policies, whether they get taken up or not depends on the government. So we can say this works, this works, this works. A government can ignore us. So it depends on which government is power, and this does have a big impact. So this is the polls from I think January. You can see what it is currently. That's what it's like in the UK. Voting really does make a big difference, and you can see that parties can come and go quite quickly. But that's the current kind of situation. Voting does make a big one. Where your money goes is big. If you've got any bank account, however much money is in it, if you're with any of these banks, they are funding fossil fuels. So a swap to a more ethical bank. There's lots of ethical banks available. I swapped to an ethical bank. Very happy with it. Just check if your bank is one of the bad guys. This also applies to pension funds as well. And where your money's invested does have a big impact. Being a role model is very important. I can see that you're in a climate hub, so you're clearly already role models already. This is fantastic. But just I think people tend to react to stories of I did this and it worked for me, especially if it's someone you know. That has more impact on someone than I possibly can. And it has more impact often than politicians and anyone else. People trust their friends and their family the most. If you can be that role model and say, right, I tried this, it wasn't actually that bad, it was fine, or this are the benefits of doing this. That's much better in some ways than just going, this is terrible, this is terrible, this is terrible. People want solutions. They want to hear the good news. I encourage you to get out there, be a role model, and do your bit. And as I can see, you're already doing that. So over to the questions on the floor over there.
So, could we have some questions from Handel? Go ahead.
Yep. Thank you, Bruce. Just that I was looking at your chart of planetary boundaries, the first one that you showed us, and the kind of the mainstream opinion is always focused on carbon emissions. But I'm just reading down through those bars and I get to biochemical flows. And I can see that those little round points, which are presumably the boundary limits, are much higher than those for carbon dioxide emissions. Could you just talk to that a bit?
Sure. Yeah. One things we notice in the lab that I work in is that you can't fix the kind of climate boundary without fixing the other ones. But with biogeochemical flows, the sheer volume of artificial fertilizers we've produced since the 1930s, and also in terms of how we've changed the proportion of livestock on the planet, that has massively modified these flows. They're way outside where they'd normally be. So it's tempting to kind of compare different boundaries. What I would say is this is almost as bad as it could be in terms of the phosphorus and nitrogen in the environment. One thing we do see is also when it flows into the ocean, we get dead zones. So you get the algae growing, the algae dies off. As it dies off, the bacteria feed on it, use up the oxygen, and you get these ocean dead zones. So there's parts of the North Sea and what we call the Ostsee here in Germany, or the Baltic Sea, trying to think of the name of it, where there are now areas where you just don't get any fish. And that is increasingly a problem. But yeah, I'd say be careful comparing the boundaries directly. It's kind of compared to how bad they could be. And also there's kind of two dots you notice on the climate change one there. One is CO2 concentration, and one is what we call radiative forcing. So this is the impact of that CO2, how much warming it's causing, and how it's changing how much energy escapes back into space. So one of those is really quite bad, but it's not as bad as it would have been if we hadn't had, for example, the Paris Accord. So that's the kind of reason why it's not quite as bad. Whereas we haven't really done anything about the fertilizer problem in most parts of the world. Some parts of the world have tried, but there is quite a powerful lobby in the production of fertilizers, which is also linked back to fossil fuels.
Thanks, Bruce. Suzanne?
Yeah, but I didn't understand what you meant when you said the Amazon, even if we stop cutting down trees, will turn into grassland. If you could just explain that.
Yeah, sure. So there is a risk. Let's pop back to that one. I'll show you the chart. It's actually easiest. There is basically we're in a risk zone. We're not quite at that tipping point, but we're basically trying to work out exactly where that tipping point will be, or as near as we can, because as you chop down forest, or because it's already lost a lot of the forest, in its original state, it would have been able to absorb more of the impacts than what it is like now. So it's very, very important we allow the rainforest to recover or protect what's existing, because the more the biosphere integrity breaks down, the less resilient it becomes, and the more likely it is to tip over into grassland. So we're not quite at the point where that will definitely happen. It's more at like 3 degrees where it's pretty likely to happen. But with any of these kind of tipping points, you start off like a 1% risk, and then a 10% risk, and a 50% risk. So we're already getting towards, I'd say in the next 30, 40 years, getting close to that point where it becomes a risk. So at the moment it's okay, but it's not that far away until we enter that risk zone. And that risk might be a low risk, but even if it's a 1 in 100 chance, it's not really a dice we want to roll. I wouldn't want to cross a bridge a bridge that's got a 1 in 100 chance of collapsing. So it's basically, yeah, the further you go to the right on that, the higher the risk that it will just flip to grassland, even if we were able to stop deforestation.
Okay, so that means that the remaining woodlands, forest lands would die off and turn into grassland by itself. Okay.
This is it. Yeah. It'll be get to the point where it's unstoppable, and shift into a new state. In the distant past, that's probably has happened before. But obviously we'd lose a huge amount of biodiversity, because in the past it would have been quite a slow change, and then nature has more time to migrate. Whereas if we push the temperature rapidly, it has less time to adapt.
Mm-hmm. Thank you.
Back.
In your opinion, what's the best line to take to affect system change? I see that, as individuals, we can do all those things, change our diet, change our energy provider, change our bank. But to affect system change because it's not just the governments, is it? It's the multinationals, etc. So what would be your view on that, please?
What I'd say with any change that I've ever seen in society, it's individuals that drive it. So even as an individual, you have an enormous amount of power in terms of when you think of society in general. Most people aren't pushing for things, so someone that is pushing for things stands out. So I would say the who gets elected does have a big impact. I'd say is a big one. So politically active does definitely help. But people are often surprised that even as an individual, if you can convince 3 people to make a change to what they're doing and explain the benefits to them, and they actually see the benefits, they'll explain to 3 people, and then you've got 9 people, and then it goes on from there. So I think that's the first thing we should recognize is individuals pushing that change that convince a few people, that convince a few people, that convince a few people, and before you know it, you've got quite a large change. And The second one I'd say is that actually it tends to be where the money is. I mean, I think it's easy to think of ourselves as not particularly wealthy, but in Europe we are, compared to the global average, fairly wealthy. So I think where we put our money has a big impact. Also, letting companies know that we're worried about it, whether that's writing a letter, whether that's doorstepping the CEO, whether that's you know, finding other ways to reach them. But public campaigns, I have actually seen them have significant impacts. If you think of all the kind of positive changes in society, anyway, it's a few individuals, and it doesn't take that many. I think it takes I think I read this something. It was about 5% of the population can generally force quite a big change. So as long as you've got 5% of the population on your side and you're pushing hard together, you'll be amazed at what you can do.
I recall reading about big fuel companies like Shell and so on investing in non-fossil fuel sources of energy. I wonder if you've got any view on that. To me, it sounds like they are projecting future, but
it's difficult. Without my work hat on here, from my past hat investigating them, sometimes undercover. I do care what I say. I'd be doubtful. Purely because based on past behavior. It'd be fantastic. I'd love to see a fossil fuel company just say to the others, okay, it's time. We're just going to completely change what we do. I think I've just been disappointed so often in the past where one said they're going to do it and then they don't, or they reverse track. But essentially it will come down to economics. And I think as fossil fuel subsidies get reduced, I mean, in the US, they're being increased, I think currently. I think was an announcement that the military is being forced to use coal. I think it was yesterday. So that'll be subsidized by the public. But I think, yeah, there's going to be a slow reduction in subsidies for fossil fuels. And just the fact that economically there are better alternatives to fossil fuels with less impact. I'm seeing that in so many countries, India and China. I mean, India has started to reduce its emissions last year. So I think for the last 14 months, Chinese emissions have started dropping, and that's likely to continue. India as well, massive increase in solar energy. I don't know if they've peaked yet, but we're starting to see countries do this, and they're doing it, on their own. And there's one or two countries that are going the wrong way. But I think businesses are starting to recognize that they have to move. So yeah, with fossil fuel companies, even they're just trying to squeeze as much money as they can, I guess, out of the last, decades that they're either allowed to do it or can do it. But I personally would be, and this is my personal opinion, I think I'd be dubious, very dubious of anything they're developing. I'd rather see a company that isn't them doing it, because any profits they make from this new tech is going to go into their other business as well.
Thanks, Bruce.
Hi, I know we're talking about tipping points and we're talking about, time. I'm interested in your timescales, because I think that's something that everybody needs to know. We're not really talking about hundreds of years or 150 years, we're talking a century. So can you give us some scales on temperatures, what's survivable, what's, where we can maintain the human existence on this planet within this century?
Yeah. Okay. So in terms of the tipping points, it's somewhat depressing, but I feel that coral reefs will be lucky to make it through this century. There will be some coral reefs that survive, but if we keep going where we're going, it's going to be very close for coral reefs. That's a very difficult one. I'd say coral reefs is the one that I personally see as the one that's
Sorry,
the one that
Is the time and the CO2 levels, we're going to go to temperature. You know, the temperature is going to rise to a certain level by the end of the century. And where are we going to survive and what temperature?
Okay. That's a huge question. I would say that it depends on, well, I mean, currently we're looking at about 2.7 to 3 degrees of warming by the end of this century. At 2 degrees, things get a lot worse. By the end of this century, the number of people that are exposed to dangerously high temperatures will obviously rapidly increase. In terms of survival, it will depend entirely on how governments react to that. I'm not expecting like a massive die-off of people. I would consider life to get much worse the longer we leave it. And I think it depends a lot on the country. Whether the country is wealthy or not will make a big difference in terms of their ability to adapt. But I think people often, when I hear someone saying, "Oh, we'll just adapt," they forget that adapting could be you lose your house and you live in a tent. We'll just adapt. Okay, yeah, but that does mean you're living in a tent and not a house anymore. So massive impacts, much worse after 2 degrees. We are losing the battle for 1.5 degrees. But I would say this, if we can bend it quickly after going past 1.5 degrees, we will still avoid the worst impacts. Yeah, it's hard to bring bad news, but it's really not good after 2 degrees. Even at 2 degrees, there's an acceleration of the worst kind of effects. But I'd say this, any slowdown, even if it's 0.1 degrees, and I often say to people like, "Oh, we're only a small country," but even 0.1 degrees less warming is a big deal, especially once you pass 1.5 degrees. And I wouldn't say like 2 degrees is like suddenly it all goes wrong. It's still like a curve that goes up. But yeah, it's bad. I don't see the entire human race going extinct. What I would say is we can compare it to the worst extinction of all time, which wasn't the one that killed off the dinosaurs. It was prior to that. It was caused by super volcanoes, which are now dormant. We don't have them anymore. Putting enormous amounts of CO2 into the atmosphere, similar rates of rise as we've got now, but I would say that was maintained for a long period. So the experts I've talked to about past extinctions, they say that it won't be a sudden die-off. If there's a sudden die-off of things, it'll be like a gradual decline. It's whether we can stop that decline is really the key question. But I would say if we can help nature recover, there is still a window open that we can stop the worst impacts. Very much so. I'm still quite hopeful that we can keep that window open for as long as possible. But even if we pass 1.5 degrees, it's a case of bending it very quickly. But I am concerned that people won't react until it gets really bad. Hopefully that answered your question. Sorry.
Thank you. So we've got 2 more questions. Let's hear both the questions and then Bruce can take them. So your question?
So my question is about artificial intelligence, which is clearly a huge subject, big economic and political drives for it. But specifically, my understanding is that these huge database banks, often in the United States, use massive amounts of energy and massive amounts of water for cooling the data banks. Now, this sounds a very worrying thing to me. Am I right to be worried? And is there anything we can do about it?
And your question? Just take the next question, Bruce.
Hello, hi Bruce. Yeah, my question was about, I think something you mentioned earlier on in your talk when you said that you are talking to the big farming businesses about better ways of doing things. Because as I see it, agriculture is one of the biggest culprits in the so-called 20th century agricultural miracle is anything but. It's basically allowed the planet to overpopulate. That's my conclusion anyway. So I would be interested to hear what some of the techniques that perhaps you're discussing with some of those agricultural sectors are.
Okay, so AI and agricultural techniques. Any last questions? One here.
Hello. Hi, Bruce. I was wondering, as you're a science communicator, if you have tips of how to talk about it with friends and family.
Great. Okay, Bruce, off you go.
Sure. Okay. So with AI, there's a report out that came out last week actually about this. The country that seems to be, in terms of how they're powering the AI from fossil fuels, the US is the worst for it by far. China does have data centers, but most of those seem to be powered by renewables, and that isn't the primary cause of the increase in energy use in China. But in the US, it's a massive one. In fact, a lot of the demand for electricity just in the last year has been from data centers. I agree, yeah, they use a huge amount of electricity. They do use a lot of water. They are a problem. I should also point out that we at my lab, we also use AI as well sometimes to basically process data. So we're trying to use it for a good purpose. And our computer is powered by kind of renewable energy. But it is a big problem. Also from my misinformation, disinformation hat in terms of pushing back against misinformation, disinformation from fossil fuel lobby groups, particularly. I would say that they are using AI in very clever ways, and that's very difficult to stop. It also worries me that there's so much AI, kind of what we call AI slop out there on the internet, where it's just videos produced, every minute. And the problem I think, is that there's so much misinformation and disinformation out there, and it tends to be if you've got money, you can produce this misinformation and disinformation. That people, it's not so much that they don't know what's right or wrong, they just can't make a decision. So there's so much disinformation out there and so much different types of information out there. They're like, I don't know what to do anymore. And then once you have a democracy that can no longer make a decision because no one's sure what's right and what's wrong, that's the risk from AI. So I'm personally hoping for regulation on it. It does seem to be a big bubble. Having worked with AI, and we've worked with AI in where I am, we're not that impressed by it, to be honest. There are some things it can do well, but there's a lot of things it really can't do well, and it does make mistakes. So we're very careful we don't use AI for writing papers, for example, because it does make mistakes. I've seen it make mistakes. So it's not ideal. So yeah, that is very much a problem. In terms of the emissions, it's very difficult to measure because there's so many data centers popping up that aren't registered as data centers. In terms of the total impact, it's very difficult to measure, but there is an increasing problem. And if it's growing exponentially in terms of data centers, that is, yeah, it's really bad. I'd be,
Could you put yourself on, Bruce, thanks. Could you put yourself on full screen for the last couple of questions?
Sure. Stop showing that. Okay. Can you see me now better?
Yeah.
Good. Okay. Second question was on agriculture in terms of what we're saying to farmers. So we're trying to encourage regenerative agriculture. So that is basically cutting back your artificial fertilizer massively. The local farmer actually in Sussex has done this, where my parents live. We live next to a farm, and he was struggling during the gas crisis in 2022 because the cost of fertilizer massively skyrockets because it's made from natural gas, basically. That's one thing we're trying to do, is trying to encourage fertilizer made using excess renewable power. So when there's a lot of wind blowing and it's not being used on the grid when it's at nighttime, the idea is you can use it to generate the hydrogen to make fertilizers. That's one thing. But this particular farmer, and this is one thing we're also encouraging, is to use green waste. So you often have the buckets where you put your green waste in, and the local farmer realized he couldn't afford the fertilizer. His farm was going to fail, and he called up the local council. He said, "Can I have some of your green waste?" And they said, "Yeah, cool. You can't get rid of it." So he covered the fields with the green kind of food waste. And within 3 years, he'd doubled the productivity of the farm. He didn't have any droughts anymore, and he's never going back to artificial fertilizer. He now uses a bag about 10 kilos of artificial fertilizer a year. That's it. So regenerative farming is working with nature more. It's using more biological controls, less herbicides, less pesticides, accepting you will get some losses, but using nature to push back against nature in a way. So using natural predators to get rid of pests, allowing the soil to basically not tilling the soil, so not overturning the soil was another one. So there's lots of things that farmers can do. But part of that has to come from the agricultural colleges, and just a kind of re-education, partly going back to the old ways, but also using modern methods as well, so they can still be productive. With cattle, I heard an interesting story from Nigeria. This was where they had a huge herd of cattle, and they realized that when they halved the size of the herd, the amount of milk per cow increased more than the halving. So they ended up with more milk by halving the herd than they would have done if they had the full herd, because there were just too many cows for the area. So there wasn't enough grass. So they were basically malnourished. And when they're malnourished, their milk production drops to very, very low. So just by halving the size of the herd, they increased the milk production massively, and they started to make a profit. So there's lots of things farmers can do. Part of it, though, is shifting what they grow and what type of animals they have. But there's lots of things they can do. But if you look up regenerative agriculture, that's what we're pushing really hard. It does work. We've seen lots of projects where it has worked, but that seems to be the thing to do. Tips then, yeah. Tips for kind of talking to friends and family. It depends a bit on who it is. If it's the kind of, I always think it's an uncle. If it's an uncle that's very dubious of it, maybe kind of like really resistant to kind of change, I think it's very, very important to talk about the benefits. Okay, this helped me feel better. This saved me money. This made my kids clap. They were happy about what I did. Anything that you talk about the benefits has much, much more impact than saying this is terrible, everything's going wrong. Yeah. So you can tell them, okay, this is the problem, but always give them a solution. I think that always works really, really well. Also, people tend to switch off if they don't understand something. So explain it in the way that relates to them. Ask them what they really care about, and find out what they care about, and then you can discuss the ways that these problems will have an impact on the things they care about. It could be they love football. Okay, it could be, okay, oh yeah, well, the match is going to get cancelled again because of the extreme rainfall. Yeah, what can we do about that? It could be that they love their coffee in the morning. Okay, the price of coffee is going to go up. Okay, because there's not enough rainfall in this area. And I think then you also then have to link it to things that are local. In fact, I didn't put the slide up. This slide I have of the water pollution in the River Ada that shot up. You could even just show them something like that. Say, oh, have you seen this? This is crazy. This is 1,000 times higher than it should be. This is the bacteria in the water. Why would that be? They might assume it's the sewage. Maybe it's some runoff from fertilizer that's run into the river that's caused the algae to grow, and the bacteria feed on the algae, and that's why the bacterial numbers are so high. So talk about local impacts on them, particularly on their wallet, particularly on their health. Guilt tripping doesn't tend to work, I'd say, as well. Making people feel guilty, they feel under attack, they push back. And sometimes their pushback from feeling guilty can be extreme. I've seen that. I had a friend that was vegan, trying to push a meat eater into not eating any meat, tried to guilt trip them. The person ended up saying, oh, I'm going to have 5 burgers this weekend just to spite you. So I'd say guilt doesn't really work. Talk about benefits. Talk about how it relates to them. Simplify it. Keep it short. And one other thing is just to show them. Say, right, look, I did this activity. Come and try it with me. Let's go and try it out. Okay, let's see if we can do it for a week. Challenge them. People love challenges. People talk about, I don't know, in January, okay, I'm not going to drink anything after New Year for a whole month. Try the same thing. Try the same thing with maybe changing their diet. See if they can do it. You can say, I bet you can't do it. Particularly if it's a competitive person, then yeah, challenges work really, really well. But that's what I'd say is some of the things that I'd encourage. Oh, I see a question in the chat.
Okay. It was a quick one.
Yeah, it doesn't have to be answered. I just would. I'm missing microplastics in your list of things, of problems.
It's in novel interest.
Ah, okay.
Yeah.
All right.
Yeah.
Okay.
There's a question in the chat.
Yeah. It's got a question relating to biomimicry. It says, how has nature solved some of these problems in the past. In terms of the planetary boundaries, I'm not sure. Dougal, if you could just clarify a bit more.
Hello. Yeah, I joined from my bedroom here as the children are downstairs watching TV. Yeah, I just think biomimicry as a kind of, I mean, I basically always ask, how has nature solved this in the past? Where is there a precedent for this problem having been solved by what combination of factors? So I think whenever you get a fiendishly complex problem like Earth ecosystem functions and outputs, then there's a kind of equally complex solution, but it can sometimes be simple. So I wonder, when addressing some of the kind of negative to positive planetary boundary tipping points, what, and you have addressed some, obviously regenerative agriculture being one of them, for example, but maybe looking at some of the more carbon intensive industries, construction, transport, manufacturing, are there kind of biomimetic things that we can do better that you're coming across?
I'd say yeah, for sure. In terms of the solutions, one place I'd actually recommend for that particularly is they're called Project Drawdown, and they have a solutions explorer. So we work with them, and they do some fantastic things. So basically, in there you can plug in what kind of sector you're looking at. Is it the building industry? Is it the transport industry? And then they will basically work out exactly what you want and give you the exact solution that you need. But in terms of learning from nature, I'd say a lot of the planetary boundaries are basically because we've disturbed nature. So I'd say that shift, particularly in diet, will have an impact on agriculture, and that shift in diet can reduce our land use. That will allow nature to kind of recover. But in terms of nature's personal solutions, I'd say, yeah, with coming back to the regenerative agriculture again, I'm afraid, using nature to kind of, for example, natural predators. I'm just thinking in Yellowstone, I think it's Yellowstone National Park, where they got rid of the wolves and then they reintroduced the wolves, and the wolves basically helped to, that's the one, fantastic. The wolves basically helped to regenerate the national park. They were having to hunt the deer to keep them under control. And they said, well, hold on, why don't we just reintroduce the nature back into there? And it basically helped the entire kind of biosphere integrity to come back together. So you've got these keystone species. For example, sharks are usually keystone species in reefs. So that would be just making sure that we protect more areas of nature. And I think recently there was a big agreement on protecting marine reserves. That's come in. But again, even if you say there's protection for reserve, that does rely on enforcement. And part of what we do in the lab is basically monitor what's happening. So with our satellite data, our ground station data, we can say, right, we work with someone called Global Forest Watch. We can now detect if an area of forest has been cut down. And this can be the area of the room you're sat in. We can tell if a tree was there before and if it's no longer there. So it's a global map, and the satellite basically detects where the trees were day by day. And it can detect when the trees are no longer there, even down to city level. So you could see your street and say, oh, the council's come along and cut down some trees in my street. You can see that on this map. And that allows people to basically not hide from basically, regulations and also environmental protection. And this also allows governments to say, hold on, we had an agreement. This particular industry is breaking those rules. We can fine them. That will help. That's one part of it, but you also need the carrot as well. So it's also about perhaps learning from nature that it only works if it all works together, and nature works because everything gets recycled. Nothing's left to waste. Everything works together, and because it works together, it works better. So I think helping maybe businesses understand that concept is not always easy, but just recognizing if we're not sustainable, your business is going to die. There's no avoiding it. So if everything you do causes harm to nature, or even if it causes enough harm to nature that you're causing a decline in the Earth's ability to absorb our impacts, eventually you're going to cause your own decline. I don't know if ever you've heard of the Darwin Awards. the Darwin Awards are where someone basically wipes themselves out by doing something really stupid. So I think it's quite important to point that out. If you're going to do something that's literally going to damage the life support that you're reliant on, that would be a pretty crazy thing to do if you're on a spaceship. So why are we doing it on Earth? But I think that's something we can learn from nature.
Thank you, Bruce. Well, I think I'd just like to say thank you very much to Bruce for the talk, and perhaps we can show our appreciation. Thank you, Bruce. Bye-bye.
Thanks, everyone. Cheers now. Bye-bye. Just one thing, if you want to check out what we're doing, is if you look up the Planetary Health Check website, planetaryhealthcheck.org is our website for the Planetary Health Check report, which goes out each year. So we basically check all of those 9 boundaries, and that's updated every year with the latest research. And the other one is our, excuse me, our YouTube channel, which is called Planetary Boundaries Science. So we'd welcome your support there and comments. So you'll see me dressed up as an astronaut in that, which is a lot of fun. Okay, in that case, have a good evening, everyone, and yeah, take care. Bye-bye.
Bye. Yeah, the Planetary Health Check website is on the bottom of all these posters which are around the room, and for those of you who've next door is the Climate Hub space, and the posters